A gyro compass is a form of gyroscope, used widely on ships employing an electrically powered, fast-spinning gyroscope wheel and frictional forces among other factors utilizing the basic physical laws, influences of gravity and the Earth's rotation to find the true north. External magnetic fields which deflect normal compasses cannot affect gyro compasses. When a ship alters its course, the independently driven framework called phantom moves with it, but the rotor system continues to point northward. This lack of alignment enables it to send signal to the driving motor, which moves the phantom step in with the rotor system again in a path where the phantom may have crossed only a fraction of a degree or several degrees of the compass circle. As soon as they are aligned, electrical impulses are sent by the phantom to the repeater compasses for each degree it traverses. To plot a position given bearing and distance from a known point, parallel rules are used to mark off the true bearing by walking them from the nearest compass rose. Dividers or compasses are then used to mark off the distance from the point. Remember that distance is measured from the adjacent latitude scale. The advantage with radar fixes is that it just needs one object to get the ship's position. We can get the range and bearing of this object and plot the same on the chart. For example, let us say we get the bearing of this light is 050 degrees and range is 4.4 nm. We will draw a line of 050 degrees to this light. The cross-track limit, XTL, could be described as the minimum safety corridor along the navigational route which is defined by end user. Meanwhile, the cross-track distance, XTD, usually represents the XTL value or individual max cross-track distance for each route leg. Furthermore, cross-track error, XTE, alarm will be triggered when the vessel deviation from the route plan is larger than the set XTL value. However, the XTL value and determination methods are still not regulated, which could mislead the navigator. Simultaneously, the XTL calculation method is rarely prescribed from companies' internal navigational procedures in accordance with the International Safety Management Code, ISM code. On board ship, it is very important to keep the updated record of the quantity of liquids, in all forms, present in various tanks. A ship is fitted with different types of automatic and hydraulic, pneumatic, mechanical sounding measuring systems wherein the level of the liquid can be checked remotely or locally without manually measuring and calculating the liquid amount inside the tank. One cannot entirely depend on the automation and mechanical devices, especially when it comes to those substances for which negligence can cause oil pollution and machinery damages. Manual sounding is always preferred by all seafarers, deck and engine crew, officer, to recheck the level of the fluid in the tanks, ensuring the tanks will not overflow or run dry in any case.